Okay, to start with, you're supposed to know the 30, 60, 90 triangle and the 45, 45, 90 triangle. And if you know them, you should be able to just tell me what's the sine of 60 degrees. So if you're going to walk me through that, how do you do it, sir? I'm going to make the triangle. While I'm making the triangle, you start thinking about how you'd explain how to do this. What's the sine of 60? What do you do? Okay, so you don't know. All right. Well, here's the angle. And do you remember SOHCAHTOA? And therefore, you are correct, sir. Square root of 3 over 2. Raise your hand if you had square root of 3 over 2. Okay, awesome. All right, on to the next one. Why don't you try finding cosine of 45? Well, I'm going to need a different triangle for that. So I'll make that in red over here. So, SH over there on the wall, cosine of 45. Talk me through it. I'm going to use this 45, but you could have used either one and get the same answer. Cosine is adjacent over hypotenuse is correct. Keep going. 1 over the square root of 2. Now, some people will say you can't leave a square root in the denominator, and that is true. In some classes, they're really strict about that. We've decided not to be strict about that because the AP tests, at this time anyway, calculus says that they don't check for this. But if you needed this to not have a square root of the denominator, do you remember what you'd multiply by on the top and bottom? Square root of 2. That way, the denominator would become the square root of 4, which would be 2, and then it wouldn't have a square root in the denominator. Here's the key. You're not allowed to divide by weird things. Do you can't divide by 0? Did you can't divide by a number that goes on forever and never repeats? That's a weird thing, right? It goes on forever and it never repeats. You're not really even sure what you're dividing it by. So that's called an irrational number. You're not supposed to have them in the denominator, but we let you get away with it at this level. Okay, one more thought. Tangent. Let's do it of 30. Perla. Opposite over adjacent. 1 over root 3. How many of you had 1 over root 3? Okay, good. Then, I think you get the basics. That's the basics. Do you get the basics involved memorizing 2 right triangles and all the angles and all the sides? And then knowing that sine is SOH, S-O-H, you know. There's a lot to know in trig. Just think about all those things that I just said. Oh, that's pretty easy. You had to know that sine is opposite over hypotenuse, that cosine is ka, which is adjacent over hypotenuse, and tangent is toa, opposite over adjacent. And you had to know 2 triangles and all 6 sides and all 6 angles, and that's a lot, and that's like the foundational basics. So this is a lot. That's why you got to keep up with it. Keep doing your homework each night. Now, I'm not going to grade last night's because I didn't really like how it was laid out. It was kind of complicated. With the angles were sometimes written in the weird places, like this is 60, but it looked like a 30. And anyway, so I'm not going to grade last night's, but tonight's very likely I will because I want to get you in the habit of like seeing, ooh, this goes in the grade book. Okay, so don't worry about last night's, but tonight's, worry about it. Get it done. And I'll cut it down to a very reasonable size. Now, here's the goal for today is that you walk out of here saying, if you give me any right triangle, all you need to do is give me one side and one angle, even if the angle isn't nice, like 30, even if the angle is like 29. All I need is one side and one angle, and I could tell you anything about the triangle. I can tell you all 3 angles. I can tell you all 3 sides. Okay, so I'm going to prove it. Let's say this side's 8, and this side is not nice. It's not 30. What if it was 29? That's the thing I'm trying to teach you today, is that you could know all the sides and all the angles just from knowing one side and one angle. All right. Now, you might not know how to do this one, but it's mostly because you probably don't know what the sine of 29 is, or the cosine of 29. What tool would help you do that? Calculator. I don't want to make today about calculators, though, so don't take it out. We're going to leave our answers with, like, sine of 29 in them. And why is it actually better to say sine of 29 degrees versus actually going and getting the decimal for it? The decimal would be what? I couldn't hear you over those guys in the hall. Hey, you guys. Okay, so the angle of 29 degrees, I totally get you're not going to memorize this, but you could know that a calculator could do it. But the calculator, do you really think that it knows every decimal forever? Do you think it really is capable of telling you a number that goes on forever? No, of course not. It's going to round it for you, and then you'll probably even round it more. So those are not exact when you have decimals. But if I leave an answer that has sine of 29 equals, let's call this A, and let's call this B. Sine of 29 is A over 8. Do you get I could solve for A? And I'll know exactly what it is. I'm just going to times by 8 on both sides. What do you mean that's solving? It's solving because A is alone now. It's solved for A. 8 times sine of 29. And sine of 29 is nice and clean because it says the answer but doesn't have it all rounded to some decimal. Would you agree that the sine of 29 must be really close to the sine of 30? And do you have it memorized what the sine of 30 is? Should memorize it. Sine of 30 is 1/2. Memorize that one. If you look at the 30, 60, 90, that's on the whiteboard in the classroom here, you can see it's opposite of hypotenuse, 1/2, right? Okay, so sine 30 is 1/2. Would you agree this must be really close to 1/2 times 8, which means pretty much half of 8, which pretty much means what? That must be about 4. So if you want to estimate, estimate. You don't need to get it super exact. If you need the exact answer, it's 8 times sine of 29. All right, let's see if you're really processing what I'm saying here. Would you please figure out for me what B is, and hint, sine isn't going to work. Figure out B. Solve for B, but don't use sine. Kind of was leading you by saying don't use sine, because then if you even try to use tangent, tangent wouldn't even use the 8. Tangent of 29 would have been A over B, and that's got 2 variables. Can you solve it if it's got 2 variables? No, not unless you have 2 equations, but we don't. So, and we could go through the work to set that all up, but all we really want is B. Then we're going to use cosine. Cosine of 29 is B over 8. Is it solved yet? No, but only needs one step. Savvy. What do you do? Correct. And now B's alone. 8 cosine of 29. Raise your hand if you had that one right. Okay, go on to the next one, which is where I don't give you anything except an angle. Think about this. Can you tell me anything that's not written up there? Yeah, you can. Can you tell me everything that's not written up there? No. What is the one thing you could tell me? The other angle must be what? 26. Okay, good. So we can know one thing, but do we know the sides? No, we can't tell the sides from that. All right. How about if, on the other hand, I don't tell you, I tell you it's a right triangle. That's key, because today we have to have right triangles still. You're going to learn trig without right triangles, but today, in fact, you start with things that are not right triangles, but we still have to make them into right triangles to do this. So we're still dependent on the right triangle. But if I tell you this is 5 and this is 12, do you get, you could actually figure out everything. What's the easy thing you could figure out? Hypotenuse. Would you guys memorize by chance? This is one of the Pythagorean triples that would be awesome to memorize. The 5, 12, something. I want to take a shot at it. It's a whole number. 13. Good call. 5, 12, 13. What if I needed to do it? Remember yesterday? Square root of 144 and 25. And is this the longest side, and therefore I should add them? It is. And get that adds up to 169, and therefore square root of 169 is If you don't have it memorized, memorize it. It's going to come up. Square root of 169 is 13. Okay, so that's the 5, 12, 13. And why did I just say that you could get all the angles too? Because you can do this special kind of trig that'll tell you the angle. Do you remember that? I know some of you are nodding like you remember vaguely that that's a thing. I'm going to show you. If that's theta, tell me what sine of theta is. It's not a trick. It's easy. What's sine of theta? 5 over 13. Then how do I solve for theta? Do you get rid of sine? Can you divide by sine on both sides? No, no such thing. You can do the inverse of sine on both sides. Do you remember the whole sine with a little -1 thing? That's the moment where you use that. Inverse sine cancels off sine. Do you get inverse of multiply as divide? Inverse of add is subtract. That's what you do to get rid of stuff, right? Is you do its opposite. It's inverse. So the inverse of sine is inverse sine. Inverse sine of 5/13 would tell you that angle right there. Well, that isn't even the goal for today, but I'm kind of just trying to go along the lines of what do you need to know. If you give me 2 of the sides, I can figure out the 3rd side, and I can even figure out all the angles. So 2 sides, you're golden. 1 side, 1 angle, you're also golden, as long as it's a right triangle. So here's a right triangle. I'm switching to the 45, 45, 90, and I know 1 side, square root of 13, and I know it's a 45 here, and it's a right triangle. You should be able to figure out everything, and since these are the same, I'm going to call them both x. Would you please solve for x? You may leave your answer with a sine of 45 or cosine of 45 in it for now. All right, PA in the back row, tell me, sine, cosine, or tangent, or did you use like a helper triangle thing, or how did you set this thing up? Just curious.
I used a squared plus b squared.
Ooh, cheater. But it works because they're the same. If these had been different, that wouldn't have worked. But he's right. Isn't it true that a squared plus b squared has to equal c squared? Yeah, that's not bad. In fact, one of the homework questions uses the same exact thing. Everybody thinks, but I can't do it because I don't have the angles. No, you can use a squared plus b squared equals c squared. All right. So I like it. So you said x squared plus x squared is equal to square root of 13 squared, which would be 2x squared, would be equal to the square root of 13 squared, which is 13. And then you could divide by 2 and then take the square root. So it's the square root of 13 halves. Very good. I like it. Now, if you didn't think of that, I don't blame you, because that's not really where I was going. I bet you a lot of you did it this way. Helper triangle, 1, 1, root 2. And a lot of you probably remembered yesterday and said, x is to 1, like root 13 is to root 2, and that gets you the answer also. Same answer. Or there's option C, which should I use sine, cosine, or tangent of the 45? Actually, only one that wouldn't work is tangent. I could use sine or cosine. Let me use sine of, let's use this 45 here. Sine is opposite over hypotenuse, right? So opposite is x. Hypotenuse is root 13. And this way, you'd leave it with multiplying by root 13 on both sides. X is root 13 times sine of 45. If you leave it like that on the test, I will have to mark it wrong, though. You know why? Because you know what the sine of 45 is. Remember just a minute ago, we were looking at the 30, 60, 90 and the 45, 45, 90. Don't you know what the sine of 45 is? Sure you do. Let's look at this black helper triangle. What is the sine of 45? Sine is opposite over hypotenuse, opposite over hypotenuse. So you can do it from the other angle and it'll be the same thing. It's 1 over root 2. So couldn't I put a 1 over root 2 here? Yeah, you could. And you should. So you end up with root 13 over root 2 again. And if you're one of those kids that's obsessed with rationalizing, it's fine. You multiply by root 2 over root 2 if you want to. Okay, there's 3 ways you could have done that one. All right, let's do one more like that. Not a 30, 60, 90. Kind of looks like it might have been. But it's actually a 20, 90, and this side is 6. I'll be specific instead of say find everything. Would you please find M? You may leave your answer with like a sine of 20 in it, because nobody expects you to know sine of 20. There's only certain angles I can expect you to know, 30s, 60s, 45s. Okay, I'm going to pause for a second and give this a shot. All right, so the student said, I did tangent of 20 is equal to 6 over m. All right, now the only thing that's hard about this one is that you have to solve for m, and m is not like in an easy spot to solve for. So what do you do first? Same kid. Excellent. And this one cancels. Now it's solved for 6. Probably not what you really want. So what do you do? Yep. Yep. And these cancel. And now I've got m is 6 over tangent of 20. I want to show you a shortcut. I think you're going to like this. Did you know this? That this and this can simply switch places. And then m is alone. And it's 6 over tangent 20. Now the only thing that's scary about this is one of those shortcuts that I'm okay with, and does save you a lot of time, but you would lose points on an AP test for not showing the work, because there's no mathematical law that says you can just switch those 2 places. There is a mathematical law that says you can multiply both sides by m. That part would be like showing your work part, but if you want, you can just switch those 2. I want to give you an example. 3 is equal to 2 over m. If you look at that quick, you could probably do it in your head and say m is 2/3. See what I'm saying? M is 2/3. Okay. So why are we doing this particularly now? Because we have a lot of these kind of problems. So it's going to come up a fair amount. Okay. So, awesome. Now, is there a chance that somebody used something else? Sure. Do you get somebody could have figured out that that was 60? No, it isn't. That was 70? And then they could have used sine, cosine, or tangent of 70? Yeah, that's okay. So it's legal. What would it have been if you had used the 70? Not sine, because that uses hypotenuse, and I don't care about that. It would have been tangent of 70. TOA is opposite side from the 70 is m over 6. And actually, that's easier, isn't it? Because there's one step. You multiply by 6 and you're done. 6 times tan 70. That would give you the exact same answer. If you actually typed it in the calculator, you'd get the same thing. Okay. So what if you don't have a right triangle, you have a not right triangle? Well, we'll keep it simple at first. Let's say that this is an isosceles. Those 2 sides are equal. This side is 10 units long. Now, from what I've given you so far, do you think you can figure out how long those sides are? not unless I tell you what. Give me what would you want to know? You need an angle. You need at least one angle. Even better if you had two angles. All right. So how about this? Can't we kind of figure out if this is 100? It's kind of sneaky, but do you get I can figure out what the other two angles are because they're the same? Know what I mean? Did you figure out that together these have to add up to 80 and therefore they're each what? 40. Now do you think we could figure out how long those sides are? Yeah, I think we probably could. Would it be handy to have a calculator? Yeah, probably would. So my approach for today, you aren't ready for something called the law of, anybody know what I would use here? There's an official name for this special rule, that the law of something. Can anybody name it? Okay, you'll be experts at this in about 2 weeks, but it's called the law of sines. There's a special rule called the law of sines, which you could use, which would mean you wouldn't have to make it into right triangles. But if I wanted to make it into a right triangle, do you see where I should draw a line? Don't say it. Just do it on your own paper. Try to figure out where I want to make a right triangle. Not there. And once I have a right triangle, I'm going to ask a key question that you're going to have to ask yourself over and over again. Do I have a right triangle with one angle and one side? Because that's what you need. Or you need two sides. Because do you get, as soon as you have two sides, you can find the third side in a right triangle, and then you have all three sides, and then you can figure out the angles from the whole, well, how do we get that again? The inverse trig thing? Okay, so either two sides or one side and one angle. How many of you were thinking about dividing this like that? Raise your hand if you were. That was smart. Now, if, this is important like little logic statements, if that's 90, do you get that the question mark would also have to be 90? It's just a law. Why? Because they together have to make a straight line, and that's 180 degrees, so therefore they'd have to both be right triangles. But let's just focus on one right triangle at a time. Would you agree that that splits this into a 50 and a 50? Because it was 100. And what's the other way we could know that had to be 50? Because this plus this had to make 90 total, right? Okay. And then since we know it got split right down the middle, don't we know that this side here has to be 5? Yep. So now I ask you, do we have a right triangle with at least one side known and one angle known? Yes, we do. So we can find everything. That's the key to today. You try to find where's my right triangle that I can make. All right, so I'm going to give you another one. This is a classic right triangle, but it isn't a right triangle. It's a right triangle that you're going to make. This is an equilateral triangle. That's all I'd have to say. And I can tell you one of the sides is 7. And you could know everything. You could know all of the angles, all of the sides. But I want to know its height. Use your knowledge of right triangle trig to figure out h. Hint, there's a right triangle in there, and you'll know one side and one angle. I'm going to pause for a second while you figure out h, and I want you to compare, including like how. Like, how did you do that? Now, if you get the exact same thing and you both have it on your paper, one of the things that annoys me is some kid will say, like, the answer is root 3 over 2. And the other kid would go, yeah, because they don't want to look stupid. They have no idea what's going on, but they go, yeah. You got to see it on both papers. Otherwise, you should be honest and say, I didn't know how to do it. And they can show you. Okay? All right, I'm going to pause for a second. Give that a try. So here's how you should have been thinking. All right, he's been telling me that I just need one side and one angle. But I can't figure out the angle thing. Well, if they're all the same sides, they're equilaterals, then they have to have the same angles. Those all had to be what? 60. How many of you made that little breakthrough? Okay, that was an important one. If you couldn't get that, it'd be really hard to do the rest. Okay, if this is a 90 and that's a 60, this must be a 30 and this must be a 60. And then I have a right triangle right here, this red one. And do I know one side and one angle in it? Then I can get anything, including the H. All right, so I would do probably, well, actually, I really like the helper triangle thing. So maybe I'd make a 30, 60, 90 like this. 1, 2, square root of 3. And if you ever question, like, is that in the right spot? Remember that the hypotenuse will always be a 2 or a root 2 on those classic right triangles, okay? All right, so then I can set up and go, H is 2 root 3 as 7 is to 2. And that would solve for H. 7 root 3 over 2. Raise your hand if you got 7 root 3 over 2. Okay, awesome. Is there another way? Sure. Do you get I could have said sine of 60 is equal to H over 7? Yeah, but you can't just leave sine of 60 in your problem. Why? Because you know what the sine of 60 is. Because of this little beauty right here, sine of 60 is a known thing. Sine of 60 is root 3 over 2. So this can be replaced with root 3 over 2 because we can get it from this. Sine is opposite over hypotenuse. Okay, and then once again, multiply by 7, and it'll be 7 root 3 over 2. Cool. 2 different ways to get it. All right, now let's go look at the homework together. So remember, it's in the same file as last night, so if you're in Notability, I just go to the same exact file you were in, and we're going to find, that was the old one, but again, like, that's not a 30-degree angle, that's a 60, and so, like, you had to trust that the drawing said 30, so you had to use 30, but I didn't like it enough that I didn't want to grade it, so I'm going to go to, and by the way, these are all good problems. Like, that one's a good problem. Notice that they made right triangles where there weren't right triangles before. That's kind of the theme for this one. This is the first slide, and you're going to do both the problems on this slide. And let me help you get started. Wait a minute, this is not a right triangle. I want to make a right triangle right there. Well, you could make a right triangle right there. You could do that. Problem is you wouldn't know what all three of these angles were, so that's not going to help very much. All right, next thought. Okay, I'm going to make a right triangle by, and I think a lot of you are seeing this, by like going like this. But you got to ask yourself, now do I have, in this blue triangle there, if I make this a right triangle, do I have a side and an angle in that blue triangle? No, I don't. I have angles. I don't have sides. That blue triangle is useless until later. But the pink triangle right here, this one, would you agree that's also a right triangle? And don't I know a side in it at least? And I actually do know this angle. Before I started drawing all over it, I had 2 out of 3 of the angles in the triangle. Do you get I could figure out the third one? I know this angle. That means at the pink triangle, I have a side and I have an angle, and therefore I have everything I need. All right, so let's get through with the suspense. If this and this add up to 150, then what's the known angle there? if this and this add up to 150, and the total has to add up to 180, must be a 30. This has to be a 30-degree angle. Ooh, it's even nicer. It's a 30, 60, 90, that pink one. All right. Now, what is the question? The question is to figure out x. But Mr. Server, x doesn't like end right there. I know. You will have to then transfer to using the blue triangle after you know their shared side. A lot of times when there's a right triangle that's sharing a side with another right triangle, and I make it squiggly black side here. That squiggly black side becomes the key. As soon as you know that side, then the blue triangle, you'll have a side and an angle. And so you can figure out everything. And you'll figure out this side, and you'll figure out this side of the pink one, and this side of the blue one, and together they will make the answer that you seek. All right, right triangles all over the place. All right, so I gave you some help getting started on that one. Here's another one. What do they want to know? They want to know x. That's this distance right here. Well, right off the bat, you got to say, I can't, it's not that simple. I can't just go, do I have a side and an angle in that red triangle? No, I don't. So I can't use that yet. You keep looking until you find a right triangle that has a side and an angle. Or, do you remember the exception? Or two sides. Remember, if you got two sides, you can figure out the third side, and you can figure out any angle you want. So two sides is just as good as one side and one angle. So that red triangle, not the ticket. Is that little triangle, well, at least it's got a side. Is there a chance I could figure out the angles in there? Maybe. Maybe there's a way I could use that red triangle. If that's not it, maybe there's another right triangle in here somewhere. All right. I don't want to give it away. You need to struggle with these a little bit. But remember what the question is. Can you find a right triangle that might be hard to see that has one side and one angle? Or, go to the next page. This is your last one. Do you get there's no angles given? But do you get there's two sides given? So can't you somehow figure out, if you got two sides, there must be a way to find a third side if you can make a right triangle somehow. And one more thing, when they did this little dashy thing here, do you get that that's code for saying this blue side and this blue side are the same as each other? And what you might not remember from geometry is if two sides are the same, then the angles across from them must also be the same. So factor that in. Those are your only three problems for tonight. Now, if you go home and go, oh, I'm stumped and I don't know how to do it, so it's not really my fault. I mean, I don't know how to do it. Then you're about to fail this semester, because you can't have that attitude of I don't know how to do it, except that you can go, where can I get help now? So you go look at the key. And if you don't know where the keys are, that could be a problem. So let me show you. In Schoology, there is a whole folder. It's blue, and it says Chapter 10 Keys. That's where all the keys are for this whole chapter. Okay, so look in the Schoology folder called Chapter 10 Keys. Open that up. Maybe you do a split screen on your iPad, and you have the answer key over here, and you get your problems over there. And use it to give yourself hints. If you just copy it, you know what's going to happen. Test will roll around, you're going to fail. But at least you'd have your homework done. I mean, it's better than getting a 0 on the homework. But use the key to learn from. Don't just copy it. Okay. All right, so only those three problems. I think that's a doable size chunk. And really, if you're not willing to do the homework, you really ought to consider, do I want to take this class second semester? Because you're going to need to. Even the A students are going to need to do their homework. Because if you want to keep that A, this is harder than last semester. And you do have, you have time to stick around and take at least one test before you'd have to make a final decision on honors versus regular. I'm not pushing you to leave. I'm pushing you that if you're going to be a slacker and go, nah, this is kind of complicated. I can't do it. If you're not going to do your homework and fight through it, then you might want to consider going to regular, because it is easier there. All right. All right, that's all I got for you for today. Have your homework done. I'm probably going to grade it tomorrow. And there's an answer key, so there's no saying, but I didn't know how to do it.